So looking at a few more examples, let's look at homework question 19. So again, feel free to pause the video and read the question. And if you feel like trying to work it out on your own, and then check and see if you're in the right direction. So one of the big things to start with is, we're in the permutation combination problem. See if you can figure out what type of problem it is. Is it a permutation or a combination? I'm going to go ahead and move forward now. So a standard 52 card deck contains four jacks, 12 face cards. Okay, that's an interesting way of phrasing that. And we have 13 hearts, all red, 13 diamonds, all red, 13 spades, all black, 13 clubs, all black. Okay, so kind of gives you a description of a deck of cards. Again, if you're not familiar with the deck of cards, it would be a good idea to kind of look that up. So of the 20,358,520 different six hands possible, decide how many would consist of the following. So we have a part A, part B, part C problem. So the first thing is we're talking about all diamonds. So as I mentioned, in our deck, there were 13 diamonds. But notice how we're not choosing all 13 diamonds. We're only choosing six diamonds. Now the question is, does position matter when you're dealing cards? And you should recognize that no, a deck of cards position does not matter where the diamonds fall in your hand. So this picks up on a combination. So part A, uh, I'm going to have a combination where we have 13 diamonds in the deck, but we're only going to choose six because we have a six card hand. So that's going to tell us all the different combinations of six card hands that are diamonds. So I'm just going to go to math, go to probability, number three, 13, and then put a six in there since they want a six card hand. That was unusual. So we have 1,716 different combinations of diamond hands. Or different arrangements, if you will. So these are six card hands. So the other thing it's asking is all black cards. So the question is how many cards in the deck are black? Well, in the deck, there are 13 spades and 13 clubs that are black. So that gives us a total of, so this is A. So B, that gives us a total of 13 plus 13 would be 26 cards that are black. So we've got 26 black cards in our deck. But again, since position doesn't matter, this is a combination. But we're only going to choose six of those 26. So again, I'm just going to use the calculator to knock the math down. So math, go to probability, choose number three, put a 26. But here we're only choosing six of those black cards. And this gives us then, whoa, 230,230. So notice how comma is kind of important to help read it. 230,230. So it's going to be the different combinations we have there. Different six card hands possible. C says all jacks. So there's four jacks in the deck, but we have to choose six jacks. So there's not six jacks in the deck, so we don't have enough cards to do that with. So this question's kind of bogus. It's because we only have four jacks. There's no way to choose six cards that are all jacks. So that's not going to be possible. So whatever that is there, it's not going to be workable. So you can't have six cards in your hand that are all jacks because there's only four jacks in the deck. I guess that's why they specified that in our problem there.